Isometry. And isometry preserves distance. And isometry has to do with transformations, something that you do to a figure, but it preserves distance when it does it. Three isometries are translations, rotations, and reflections. When you're done with the translation, when you're done with the rotation, when you're done with the reflection, the size of the original figure stays the same. It might be in a different place, but the size stays the same. The size of the figure, a triangle, quadrilateral, whatever. No, dilation is not an isometry. Dilation actually reduces or magnifies, so the lengths do change. Some terms that we need to know. The pre-image is the before look, and the image is the after look. Translations and rotations. Okay, let's start with the translation. A translation implies the sliding of the figure. To do the translation, you need a direction and a distance. That information is contained in the slide arrow. If you notice, this is the pre-image and this is the image. And you can know that because these have primes. The primes are the image. The pre-image is where you started. So this triangle is now in a new position. And it moved this much in this direction. So this is a arrow that's giving us the information, the slide arrow. This triangle moved this much in this direction. So this is the pre-image and this is the image. Find the image of line segment AB under the translation. When they say under the translation, what they're saying is, where is line segment AB after you slide it around? So we have line segment AB, and here's our slide arrow. So we're going to move this segment, this amount, the length of the slide arrow, and in this direction. This is going to be the new position of line segment AB. It's going to be line segment A prime, B prime. How do you do it? You get the easy points, which are the ones at the end. You could get the ones in the middle, but those would be hard. Get the ones at the end. So this A, we're going to move it down twice and twice over. So down twice and twice over. This is its new location. Now go for the B. Down twice and two over. This is a new location. Tie those together, and this is the image. They could also give you information as to where you're going to slide it, in which direction, how much. Using some algebra. This is the original point location. And what this is saying is that you're going to get the x coordinates and you're going to add 4 to them. You're going to get the y coordinates and subtract 3. So notice that's what we did to all the x's. We added a 4. And what did we do to all the y's? We subtracted a 3. After you simplify, this will give you the location of the image. So if you go and identify these 3 points, that would be these 3 points here. Those are the coordinates. If you identify these coordinates, these would be the 3 coordinates and their locations. Pre-image, image. So if this was split this way, given this information. Now rotations of the transformations, the 3 we mentioned, translation, rotation, reflection. This is the most challenging, but we're going to just concentrate on easy rotations, 0, 90 degrees, 180, 270, 360. For other rotations, you would need a compass or protractor. So what do you need to accomplish a rotation? You need a turn center. About which point are you going to rotate? A turn angle. How much revolution is it going to be? How much are you going to revolve about this center? And in which direction? Is it clockwise or counterclockwise? And that's what this says. Number 1, rotate about which point? Number 2, how much to revolve? And number 3, is it going to be clockwise or counterclockwise? And they give you a figure that has that information. If you look at this, this is the information, the 3 pieces of information we need. This is how much we're going to revolve. This is a 90-degree angle. We're going to revolve about, we're going to go counterclockwise. So that's why the arrow's pointing that way. And then we're going to revolve about this point, point O. So what you do is just imagine you tie this, you're going to tie each one of these vertices, or the easy points to pick, tie them, and then revolve them 90 degrees. Tie the C, revolve it 90 degrees. Tie the B, revolve it 90 degrees counterclockwise. So if you do that, take for example the A. What would be 90 degrees? Well, if you're going to tie it up here, this would be 90 degrees. So this A takes its new position right here, A prime. Now get a hold, tie up the C. What would be 90 degrees? 90 degrees would be like this, here and here. So you revolve it 90 degrees, and this is where it ends up. Now you could tie these two. That would be where this segment, this side of the triangle, is going to end up. It's going to end up right here. And notice that this one's easy because if these end up here, well, the B is going to end up right here. So there it is. This is the pre-image, and this is the image. A half turn, all it means, it's a rotation of 180 degrees. Remember, like a straight angle, right? 180 degrees. So notice if you revolve this figure counterclockwise, that half a turn, that's 180 degrees. This is where it's going to end up. This is the pre-image, and this is the image. Notice if you revolve this one counterclockwise 180 degrees, this is where it's going to end up. This is the pre-image, and this is the image. And notice what it says here. You get the same result clockwise or counterclockwise. It doesn't matter. You end up in the same result when it's a half turn, 180 degree revolution.